Hi Akib. Hi Akib.
Hi, sir.
How are you?
I'm fine.
Okay. So today we'll be discussing similarity of triangles, right?
Yes, sir.
Okay. So we'll be starting with the basic concepts, the very beginning of similarity of triangles. In fact, for all figures. Very important point. I assume you have studied congruent triangles,
Uh,
right?
yes, sir. But I
Okay.
have forgotten
Okay. No problem.
the
Uh,
recap.
okay. Fine. Can you see the screen?
Yes, sir.
Okay. Uh, all congruent figures are similar, but all similar figures need not be congruent. Congruency is, first I'm talking about congruency. Congruency is when two figures are exactly same except the name. Okay.
Yes, sir.
So on the screen you can see triangle ABC and triangle PQR. If I give the information, the sides are 5, 6 and 7. And here the sides are 5, 6 and 7. So these two triangles are exactly same in terms of sides. Okay. The only difference is that they have different names. So we say that these two triangles are congruent. Okay. I'm not going into details of congruency. Now we'll be learning about similarity. As you can see in this figure and the small bigger figure, right? These two
Yes, sir.
triangles have certain similar properties. The only difference is that this is a smaller one and this is a bigger one. Okay. So these two
Yes.
triangles are said to be similar. Now there are certain rules by which we can prove that two figures are similar or no, right? Okay. So let's come to that rules. Before we move on, we can see that quadrilateral ABCD and quadrilateral PQRS looks like similar, right? Let's
Yes.
be specific with the information. Let's say side AD is 5 and this side is 10. And let's say side AB is 6 and this side is 12. So for sure we can say that these two quadrilaterals are similar. Why similar? Because the ratio of quadrilateral ABCD, sides of quadrilateral ABCD and sides of quadrilateral PQRS. If you compare the sides 5 and 10, what is
1
the
is to
ratio?
2.
1 ratio
1 is
2.
to 2.
That's great. Similarly, the side ratio of 6 and 12 is also 1 ratio 2. Okay. That is why I
Okay.
said that these two quadrilaterals are similar. Let me give you a important point. If you compare 5 ratio 12 and you compare 6 ratio 10, then they are not equal, correct?
Yes.
It does not mean they are not similar. So to check the similarity, you have to check all possible combinations of sides, right? When I
Yes, right.
when I selected 5 and 12 and 6 and 10, I find that these two ratios are not equal. But when I selected 5, 10 and 6, 12, I found that these two ratios are equal. So you will have to select all combinations to check whether they are similar or no, because you have to check their ratios are same or no, right? So yes, they are similar figures. And how do we write the similar figures? We write A, B, C, D is similar to, we can write quadrilateral, QUAD is similar to quadrilateral PQRS. Okay. So the method which I told you just now is called side-side proportionality. Okay. SS proportionality, correct?
Yes,
Okay.
sir.
Now we'll be learning all the proportionalities uh, to check that two triangles are similar. Okay. Can I raise the
Okay.
screen?
Yes, sir.
Okay. Perfect. Okay. Before we move on, let's quickly do some questions. Have a look at question number 1. All circles are congruent or similar?
All circles will be similar,
Similar.
as we have studied that the that all congruent figures are similar, but the similar figures need not to be congruent.
For sure, all circles are not congruent because all circles are not all equal in the area, right?
Right.
But all circles are similar because they can have different radius. Okay. So this is a smaller one, this is the bigger one, and this is the biggest one. Of course, there would be other bigger circles. So we can say that all these circles are similar to each other, right? So,
Right.
okay. Number 2, all square are,
Similar, we can say.
yes, similar. Number 3,
Number 3, isosceles, I think, because all triangles cannot be equilateral if you compare with the sides and the angles.
okay. Let's read the statement again. If you say all isosceles triangles are similar, so let's say this side is 5, this side is 5, okay, and this side is 7, correct? We
Correct.
can have another isosceles triangle with the side 5, 5, right, and 6. These two sides are equal, but the third ratio is not equal, na?
Sorry. I
Right?
haven't read the statement properly. So it will
Yes.
be equilateral.
Of course, it will be equilateral. Let me give you some examples. Let's say there is an equilateral triangle with the side 5, 5, 5 all, okay, and there is another equilateral triangle, let's say 7, 7, 7. There is third equilateral triangle, let's say 9, 9, 9. So you can say that 5 ratio 7. What is the ratio? 5
5
ratio
is to
7.
7.
Okay. Another side ratio, another side ratio, this 5 and this 7 when I select, again the ratio is 5 ratio 7, right? And
Right.
the third side ratio, 5 ratio 7 is again. So all these three ratios are equal, correct?
Correct.
So we can say that first triangle and second triangle are similar. Okay. Similarly, if you want to compare first and third triangle, they would also be similar because their side ratios would always be 5 ratio 9. Correct or no?
Correct,
5
sir.
ratio no, 5 ratio 9, 5 ratio 9. So we can say that all equilateral triangles for sure would always be similar. Okay.
Okay.
No problem.
No problem, sir.
Okay. Let's come to question number 3. Let me raise the screen. Tell me number 3, please.
Yeah, they are similar because the ratio of the sides are similar. 1.5 is to 3, that is 2. So all the sides, the ratio are similar.
Our
So we
ratio
can
are
say that,
similar. Yes,
so
yes.
we can say that a
You
quadrilateral
are
is similar.
right till what we have learned, but these two figures are not similar because
Because it is a quadrilateral and it is a square.
yes, this is a rhombus and this is a square. These two are not similar figures. Okay. Yes, if you compare a rhombus with another rhombus of side 3 centimeter, of course we can say they will be similar. You understand?
Yes, sir.
Yes. So my point is that to check the similarity, only the side ratios do not decide. There are other factors also which decide, like an angle also, right?
Right.
So till now what we have studied is the limited study of proportionality. Okay. So the answer for this is that this is rhombus and this is a square. Even though their side ratios are equal, they are not similar. Make sense?
Yes, sir.
Good one. Move on. Okay. Very quickly, to have a good understanding, let's know about theorem 6.1. It says that if a line is drawn parallel to one side of the triangle, let me tell you with example. Let's say we have a triangle, triangle ABC, and if there is a line drawn PQ, which is parallel to AC, which is parallel to BC. PQ is parallel to BC. Okay. Can you say that P is the midpoint of AB?
We can say that because it is parallel.
Parallel does not mean P will be the midpoint. No? Midpoint means it is exactly in the middle of AB. Is point P exactly in the middle of AB?
No.
No. Like it may be, it may not be, right? If I draw in the midpoint, it can be. But P may or may not be the midpoint of AB, right?
Right.
Q also may or may not be the midpoint of AC. Okay. So the only information is that line PQ is parallel to BC. Okay. If this happens, in a triangle, then we can say that, please listen very carefully. Point number one, we can say that AP over AB. I'm talking in a small triangle and in a bigger triangle. In a small triangle APQ and in bigger triangle ABC. Okay.
Yes, sir.
So side AP over side AB. A small triangle is side AP and bigger triangle is side AB, right? And then I'm saying small triangle side AQ and bigger triangle side AC. So see carefully. AQ over bigger triangle side AC, right? And
Right.
then I'm saying a small triangle side PQ and bigger triangle side BC. Correct?
Correct.
If in any triangle, again repeating, if in any triangle side ABC, if you draw a line PQ which is parallel to BC, then we can always say these things. Point number one about the side ratios. Okay.
Okay, sir.
We are not saying anything. We are just taking the three different side ratios of these two triangles. Correct.
Correct.
Okay. For example, let me give you an example. In triangle ABC, let's say we have drawn a line EF parallel to AC. Correct. And
Correct.
the side is, this side is 3, BF is 3, and BC is 7. BE is 4, AB we don't know. Correct.
Correct.
Okay. So what we can say, we can talk in we can talk about the smaller triangle ratio and the bigger triangle side ratios. So see very carefully, what can I say? I can say a smaller triangle is BF over bigger triangle is what? BC,
BC.
right? And
Right.
similarly, a smaller triangle BE over bigger triangle
BA.
BA, right? Okay,
Right.
so filling up the information, BF is what? 3 and BC is 7 and BE is what? 4
X. 4
and
upon
that
X.
is X. Okay, and so solving for that, so X value is 28 over 3. I hope you know the basic calculation.
Yes, sir.
No problem, fine. So this example I gave you for point number 1. Okay, similarly, under the same condition, we can talk about the second point. Second point is also equally important. Let me erase the calculation here. Let me erase it. In triangle ABC, I'm doing the same figure. In triangle ABC, PQ is a line parallel to BC. So the second point is, I'm not taking the two triangles this time. I'm taking the two pieces of side AB. So look carefully. AP over PB will be equal to AQ over QC. I have taken the two pieces of side AB and side AC. This side AB got two pieces, AP and PB, right? And this side AC got two pieces, AQ and QC. So these two ratios will be equal. Make sense?
Yeah, it makes sense.
Okay. The example for this is, let me erase everything else. If I say that there is a triangle ABC and this is parallel to this PQ, and this is X, this is 4, this is 5, this is 8. So can you find the value of X?
Yeah, I can find the value of X.
Yes. So we will talk about the two pieces of BC. So two pieces of BC in an order is BQ and QC, right? And the
Right.
two pieces of BA is BP and
And PA.
PA, right? And then you can plug in the values, get the value of X, right?
Right, sir.
Perfect. Let's move on. Okay. Do you have any doubts on this topic, what we are studying? Or should we come to the similarity?
Uh, yes, sir. We can
We
come to
can
the
come to the
similarity.
similarity. Fine. Okay. So there are certain criterias for similarity on which we can decide that two triangles are similar or no. So those theorems are, the first theorem I am explaining is AAA. Okay. Let's say in these two triangles, triangle ABC and triangle DEF. Okay, I'm just explaining the theorem, not trying to prove it. In triangle ABC and triangle DEF, the AAA similarity says that if angle A and angle D are equal, and if angle B and angle E is equal, and if angle C is equal to angle F. So you can observe that these two triangles have all the three angles equal to each other, right?
Right, sir.
So these two triangles will be similar under the rule AAA similarity, means angle, angle, angle similarity. AAA means angle, angle, angle. So it means the three angles, if it is equal for two triangles, then those two triangles will be similar, right?
Right, sir.
Okay. Now here I would like to mention that sometimes you can have just two angles equal. And if two angles are equal, by default the third angle will also be equal, na?
Right.
Why? because the sum of all angles has to be 180.
180.
For example, let's say this angle A is 70, angle R is also 70. Okay. And angle B is 50 and angle Q is also 50. So whether or
And
not angle C will be what?
si- uh, 60.
180 minus 70 minus 50, which will be 60, right? And
Right, sir.
similarly, angle P would also be 180
60.
minus 50 minus 70, right?
Right, sir.
Which will again be 60. So the third angle has to be by default equal, right? Okay. So we can say that if the two triangles have two equal angles, then by default the third angle will be also equal, and
Right,
hence
sir.
those two triangles will always be similar. Okay. So we don't need to say necessarily about the third angle. Correct?
Correct, sir.
Good one. So that is why AAA or AA is the same thing in terms of similarity. Fine, let's move on. This was the first method of checking similarity. There are different criteria. Any triangle may not fit into one criteria but can fit into other criteria. So you will have to apply all of them. Okay. Now we are learning the second condition for two triangle similarity, that is SSS. Let's say the two triangles are ABC and PQR, and the similarity SSS talks about three equal sides. Side, side, side. S is for side. Okay. So side, side, side means if two triangles have three sides equal. For example, side AB is 5 and side QR is also 5. Side AC is 7 and PR is also 7. And side BC is 9 and PQ is also 9. So what we are finding here is that the two triangles have equal sides, all the three sides equal to each other, right? So we don't talk about the side ratios. Sorry. We always talk about the side ratios. In this case, side AB and side QR ratio is what? 5:5.
1:1.
1:1. Side AC and side PR ratio is what?
Similar as side AB upon QR. That is 1:1.
1:1. Okay. So we always talk about the side ratios. Side BC and side PQ ratio is what? 9:9, which is 1.
1 is
Now,
to 1.
because the ratios are equal, the side ratios are equal. So we say that these two triangles are similar to each other, right?
Yes, sir.
Okay. Let's take another example. Small triangle ABC and bigger triangle PQR. AB is 5, QR is 15, BC is 3, PR is PQ is 9, AC is 4, PR is 12, let's say. So now when I am comparing the two side ratios, as I said before, it is all depending on your different selections. So when you compare 5 and 9, 5:9, let's say if you compare 4 with 15, right? So you don't find the side ratios equal.
Yes, sir.
Okay. It does not mean these two triangles are not similar. So you have to check all different combinations. So have a look, please. When I am selecting side AB and side QR, what is the side ratio? 5:15, which is 1:3.
1:3.
When I am selecting side AC and side PR, what is the side ratio?
4:12 or 1:3.
1:3. And the third side ratio will also be equal. You will have to check. Okay. BC and
Yes,
PQ,
sir.
when you check, you get 3:9, which is 1:3. Now,
Oh,
because all three side ratios are 1:3, 1:1:3. So yes, we can say that these two
two
triangles are
triangles
similar.
similar.
Okay. Now, after being similar, the condition is very important. Okay. Now listen to me very carefully. After you decided that these two triangles are similar, let me mention the sides. This was 5. So we'll say triangle ABC is similar to triangle PQR. Correct? And how
Correct, sir.
did we decide they are similar? We decided by
Side ratio.
side proportionality ratios, right? Okay. Now, after they are similar, their opposites angles. We had selected which side? We had compared side AB with QR, correct?
Correct, sir.
Side AB and QR we compared. So side AB opposite angle is angle C and side QR opposite angle is angle P. So we can say that angle C will be equal to angle P. Why did we selected C and P only? Because we compared side AB with side QR while comparing, right? AB
Right,
with QR.
sir.
So their opposite angles will be equal. Okay. Now let's have a look at
Sir,
AC and
can you
PR.
prove, sir, can you prove that how the opposite angles are equal?
Not right now. Okay. This session is only for understanding similarity. Yes, we can prove after being similar.
Okay, sir.
Okay. Not right now. Right now, we're just learning the similarity condition. Okay. Yes, we can learn that in the next session. Side AC and side PR we selected. So side AC opposite angle is what? Angle B.
Angle B.
And side PR opposite angle is what?
Angle Q.
Angle Q. So we can say angle B is equal to angle Q. And side BC and PQ we selected, we compared. So side BC opposite angle is angle A and side PQ opposite angle is angle R, right? So we can say angle A is equal to angle R. Is that good?
Yes, sir.
Fine. And then we have a third proportionality rule. What you asked, Akib, we can prove that in the next session. Okay,
Okay, sir.
fine. The third proportionality rule, the third rule to check similarity is SAS. SAS. As the name suggests, side angle side. So we talk about the two side ratios because in similarity we always talk about the side ratios. So two side ratios and in between angle have to be equal. For example, let's say in this triangle ABC and triangle DEF, let's say if side AB and DE side ratio is equal to side AC and DF. So if this happens and also angle A in between angle have to be equal. Angle A is equal to angle D. And if this also happens, then we can say that triangle ABC is similar to triangle DEF,
DEF.
right? So again repeating, if the two side ratios are equal and in between angle is also equal, then the two triangles are said to be similar by property SAS. Okay. For example, let me raise the screen. Let's say this side is 5, this side is 7, and side AC is 2.5, and this is 3.5. Okay, and in between angle, let's say is angle A is 60 degree and angle D is also 60 degree. So we compare the side ratios. So when I compare AB with DF,
DE, DF.
let's say we don't know, right?
Oh, okay,
Let's
okay.
say, okay, AB with DF, when I do 5 over 3.5, and AC with DE, when I compare 2.5 with 7. So we find that these two side ratios are not equal, right?
Right, sir.
Okay, because we have to select different combinations. So now we'll try a different way. Try to compare with different sides. That you will always have to do the trials. Okay. So side AB, now I am comparing with DE, and side AC I am comparing with DF. Let's see
DF.
what happens. So AB over DE side ratio is 5:7, and AC DF side ratio is 2.5 over 3.5. Okay. When I cancel the decimal, I get 25
5
over
over 7.
35.
5 over
And
7,
now,
sir.
yes, that is 5/7. That's great. So we find that these two side ratios are equal. Okay, that's great. And in between angle is also equal. Angle A is equal to angle D. So yes, we can say that triangle ABC is similar to triangle DEF. Okay.
Right,
Now,
sir.
after they are similar, the after properties are equally important. After the two triangles are similar, what can you say about angle B? Please understand, we compared side AC with DF, right?
Right, sir.
So AC opposite angle is B and DF opposite angle is angle E.
E. So they
So we can say
angle B and angle E, they will be
are
equal.
equal. Yes, right. And we compared side AB with DE, right? So side
Right, sir.
AB opposite angle is C and side DE opposite angle is F.
F.
So we can say angle C is equal to angle F. No problem.
No problem, sir.
And then there is third side ratio which we don't know. Side BC and EF we don't know. But for sure we can say that BC and EF side ratio would also be the same side ratio what we had for the other sides, which is 5:7. Okay. The third side ratio BC and EF will also be 5:7 because the other side ratios were 5:7. Make sense?
Yes, sir.
Yeah. So these three things will happen only after the two triangles are similar. No problem.
No problem.
Okay. One important point again, because let me give you a question. If I say triangle PQR is similar to triangle XYZ, so without looking at the figure, can you tell me angle P will be equal to which angle? If these two triangles are similar, then the first angle, angle P, will be equal to this first angle, angle X. That is a
Yes,
must.
sir.
Okay. That is how we represent. Like if somebody says PQR is similar to XYZ, that never may happen that angle P will be equal to angle Z. Okay. So angle P will always be equal to angle X. And so angle Q would always be equal to angle Y. And so angle R will always be equal to angle Z.
Z.
And also side PQ ratio and XY ratio, right? Can you see the
Yes,
pattern?
sir.
PQ
Yes, sir.
ratio with XY ratio and QR
Right, sir.
ratio with YZ ratio
And PR with
and PR
NZ
with
with XZ.
XZ. Yes, PR with XZ. These ratios will be equal. Without looking at the figure, just based on this information, we can say all this thing about the two triangles. Make sense?
Yes, sir.
Good one. Let's come to the examples now. Let me raise the screen. When we'll do some questions, then we'll have a better understanding. Okay. Do you want to do these questions or do you want me to explain you? Means should I give you my questions? Okay. Uh, Very easily. Can you do number 15, please? Okay, let me explain. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground. So there is a pole, this pole, which is at a height of 6 meter, and the shadow is always on the ground. That shadow is 4 meter long. That should be a smaller one. Okay. So this is a 4 meter long shadow, right? Okay. Let's join them. Okay. And then at the same time, a tower casts a shadow 28 meter long. So there is a tower, separate tower somewhere at the same time, which casts a shadow of 28 meter. They are asking find the height of the tower. So we have to find the height of the tower. Let's say the tower is T, O, and this shadow is OS. Okay. And this triangle is triangle ABC, right? Because it is the same time, so the side ratios should be equal. Okay.
Okay, sir.
Because the triangles will be similar. Why triangles will be similar? That is important. Please understand. I will explain why it is similar. See, the making of shadow depends on the sun, right? So sun is will make the same angle with the ground as the sun here makes the angle with the ground. Like wherever you stay, at the same time you will have to make your eyes up by the same amount of angle, right? That is why I'm saying, let's say you are standing whether at C or you are standing at S. At the same time, the angle will always be equal. Make sense?
Right, sir.
Okay, that's great. And because this angle is 90-degree, right?
Right, sir.
So what we decided is that angle C will be equal to angle S, and this is 90-degree is equal to this 90-degree, right? So triangle ABC and triangle TOS have two equal angles. So can we say by AA similarity method what we had learned in AA similarity? That when two angles are equal, the triangles will be similar, right?
Similar.
So
Right,
here
sir.
two angles are equal, so we can say triangles are similar. And after being similar, the equal angle side ratios will be same. Okay. So listen to me carefully. The equal angle side ratios are what? Angle C opposite
OB
side is
upon TO
AB.
equals
Yes.
to
Yes. So angle C and angle S opposite
AB
side,
upon BC equals to
AB over TO. AB over TO. Opposite angle, opposite side
yes, sir.
ratios. Correct? No problem. and angle A
Right, sir.
opposite side is 4 BC and angle T opposite side is OS. So I will compare BC with OS. Why did I compare BC with OS? Because opposite angle, angle A is equal to angle T, right or no?
Right, sir. Right, sir.
And after being similar, means after we decided by A similarity they are similar, the two side ratios will always be equal. And so we put in the value. So 6 over TO, let's say, is X, is equal to BC is 4 and OS is 28. While simplifying, we get X equal
1
to
over 42.
42,
Sorry,
not 1
42.
over, just 42, right? So 42 watt. Units are always important meters. Okay,
Okay, sir.
fine. Let's have a look at some more properties of areas of similar triangles. Okay, hope you're not exhausted. Akib, hope you're not tired.
No, sir.
Okay, fine. Uh, Now, what we are learning new is if there are two triangles which are similar, if triangle ABC is similar to triangle PQR, okay, then the corresponding side ratios square will be equal to the ratio of their areas. Let me explain you, don't worry. If I say triangle ABC, if I say is similar to triangle PQR, okay. Now, because I said ABC is similar to PQR, so I mean that side AB and PQ side ratio, correct,
Correct, sir.
is equal to side BC and QR side ratio is equal to side AC and PR side ratio. These three side ratios will be equal. No problem.
No problem,
So
sir.
this theorem says that the square of these side ratios, square of them, they will always be equal, and they all will be equal to the area of triangle ABC over area of triangle PQR. Is that good?
Yes, sir.
AR means area. So again repeating, if two triangles are similar, then their corresponding side ratios square will be equal to the ratio of their areas. Correct?
Correct, sir.
That's nice. With an example, let me mention you that. Let's say side AB is 2 and side QR is 5. Let's say side BC is 3 and this side is 7.5. Okay, and this angle B is equal to angle Q. So first of all, you have to decide, is triangle ABC similar to triangle PQR?
No, sir, because the side ratios are not similar.
You will have to check all the combinations.
Right, sir.
You cannot compare 2 with 7.5, 3 with 5. Yes, you can compare, but because you are unsuccessful, you are not getting them, the side ratios equal, it doesn't mean they will not be equal. Okay, you will have to check other combinations. So check 2 with 5. So that is 2:5. That's fine. Check 3 with 7.5. Let me check. So 3 over 7.5. Multiplying up and down by 10, we get 30 over 75. Correct?
Correct,
Simplifying
sir.
them by 5. So 6 over 15.
Sir, we are getting 3 is to 2. Sorry, 2 is to 3.
2:5.
2 raised to 5. Sorry, sir.
Correct. So they are equal now.
Yes, sir.
right? So let me mention that side AB I compared with QR and side BC I compared with PQ, correct? And because in between angle is equal, angle B is equal to angle Q. So yes, these two triangles are similar for sure, right?
Right, sir.
Angle Q is equal to angle B. So yes, these two triangles are similar by which property?
Side angle side.
Okay. So what should I write? Triangle ABC with PQR should I write?
Yes, sir.
No. I cannot say triangle ABC similar to PQR. That's wrong. Please understand. The corresponding side ratios I compared AB with QR.
Oh, oh.
So
So
AB
it will.
triangle QRP you will say. You understand?
Yes, sir. Yes, sir.
If you say PQR, that is wrong. They are not similar. Yes, triangle ABC is similar to QRP. That's right. Good. No problem.
No problem, sir.
How did we prove them they are similar?
By side angle side.
Side angle side. Okay. Now this theorem says that if they are similar, so yes, we proved they are similar. And let's say triangle ABC area is 10. So what will be the area of triangle PQR? So what we learned is in this theorem is that side ratio is square. So what is the side ratio? 2:5, correct?
2:5. Yes, sir.
So 2:5 square will be equal to the ratio of their corresponding areas. So corresponding area of triangle ABC is 10 and PQR is X, correct?
Correct, sir.
So 4/25 is equal to 10 over X. So X equal to 250 over 4, which is 125 over 2, which is 62.5.
5.
So area of PQR is 62.5. Is that okay?
Yes, sir.
Fine. Let's come to the next information. Okay. Uh, let me extend you that knowledge what we learned just now. The knowledge is that maybe it is not given here, that if triangle ABC is similar to triangle PQR, so let me mention that triangle ABC is similar to triangle PQR. Just a moment. So if these two triangles are similar, then of course the corresponding side ratios will be equal, right, Akib?
Yes, sir.
Okay.
Right, sir.
Then of course their corresponding areas will also be equal
Yes, sir.
to the areas will be equal to their side ratios square, right?
Right, sir.
Okay. Now my point is that side ratios will be equal to the corresponding median ratios, okay, and corresponding angle bisector ratios. Is that good? I will show you the example.
Yes, sir.
Let's say point D is a midpoint of BC and for angle A it is P and S is a midpoint of QR, right?
Right, sir.
Side BC and side QR, corresponding side ratios. I compared BC with QR, right?
Right,
Okay.
sir.
So if it is given that D is a midpoint of BC and S is also a midpoint of QR, so it means that line AD is called median. right or no? You know median, right?
Yes, sir.
Median means the line joining the vertex to the midpoint of the opposite side. So line AD is the median and line PS is also median. So you can say that, let me write everything. AB ratio PQ will be equal to BC ratio QR, will be equal to AC ratio PR, will be equal to the median ratio AD ratio PS. Is that good?
Yes, sir.
Similarly, if there is a perpendicular drawn from B to side AC, okay, and a perpendicular drawn from Q to side PR, please understand, I have drawn the perpendicular on side AC and on side PR, correct? So the
Yes, sir.
corresponding altitude we are talking about, right? Let's say this is M and this is N. So the corresponding altitude will also be equal in ratios. BM ratio QN. No problem.
No problem, sir.
Is that good?
Yes, sir.
One more property. The corresponding angle bisector will also be equal. Let's say I'm drawing an angle bisector from angle C. Okay. Angle C, I am making an angle bisector. So let's say this angle is CX. This line is CX. Okay. And because I selected angle C, I am talking about angle R. And angle R, angle bisector, let's say is meeting at Y. So what we got is, if XY and YR are the angle bisectors, right? So these angle bisector ratios will also be same. XC over YR will also be same. Make sense?
Sir, it is necessary that if we are bisecting an angle, it will be drop on the opposite side with
Midpoint. No, 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 no.
midpoint.
No, 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 never. Angle bisect, drawing an angle bisector doesn't mean it will meet the midpoint of the opposite side. Never. For example, for example, let's say you have this triangle. Okay. When angle bisector, when I am making, this angle will be 30-30, whereas the midpoint is here now.
Yes,
You
sir.
understand?
Okay. Okay,
So
sir.
angle bisector doesn't meet to the midpoint of the opposite side necessarily. It will only meet. It will only meet in equilateral triangle.
Right, sir.
Okay. And for one angle in isosceles triangle, let me make this point very clear. Yes, there is a lot of confusion about this. Let's say, for example, in triangle ABC, let's say side AB and AC are equal. So if you draw an angle bisector from angle A, right, that will
Right,
meet
sir.
the midpoint of BC. Yes, you are right. BD will be equal to DC. But if you draw the angle bisector from B or from C, they will not meet the midpoints of the opposite side. Make sense?
Yes, sir.
Good one. That's a nice question. Yeah, okay. So important is that after being the triangle similar, all these side ratios, this median ratio, let me write it, median ratio, altitude ratio, altitude means perpendicular, and angle bisector ratios. All these ratios will be equal. Okay. And I'm extending this information. All these ratios, because they are equal, so they will be equal to the, means their squares, I mean, right? So
Yes, sir.
square of these ratios will be equal to the area of triangle ABC and area of triangle PQR ratio. Does that make sense?
Yes, sir.
That's nice. Very nice. Okay. Let me erase the screen. So we end our session today here, Akib. do the practice on all questions. Okay.